In this video, we'll talk about how to use the geometric series formula. And first we'll just mention what a geometric series is. So this big sum right here is the prototypical geometric series. It's formed by taking these two parameters. One is x, which is a variable, and it could be any real number, and one is n, which is a non-negative integer. And then to form the geometric series, you take consecutive powers of x that start at 0. Notice that 1 is the 0th power of x, and end at n, and you add all these together. That's what a geometric series is. So in particular for this video, we're interested in using the formula, and it turns out that this sum, which has a bunch of terms in it, mostly contained within these dots, this sum is actually equal to 1 minus x to the n plus 1 over 1 minus x. And notice the power on the right hand side is 1 greater than the highest power on the left hand side. And then the denominator, it's always 1 minus the variable. Also notice that this formula only holds if x is not 1. Otherwise you would divide by 0 in the bottom, so the formula just doesn't work. So this side, we often want to write in this more concise notation that uses sigma. And we're going to write this as sigma meaning sum of a bunch of things that look like this. These are called the terms. And they look like x to the I, where I starts at 0 and ends at n. That's what that notation means. And so again, this means the sum of things of the form x to the I, where I starts at 0 and goes to n, and it increments by 1 each time. And then the right hand side stays the same. So this is our more concise geometric series formula. So we're interested in applying the formula, not deriving where it comes from. So for our first example, let's just plug in a couple of things for these parameters. So let's say x is a half and n is 10. And let's say our problem is find the value of the geometric series with these parameters. In other words, find the value of this geometric series, I equals 0 to 10 of 1/2 to the I. What we need to do is identify in this formula what corresponds to the parameters here. So this left hand side I'm not going to change, but I will notice that since x is a half and n is 10, then if I plug into this formula, this right hand side, then I get this 1 minus 1/2 to the n plus 1, but n is 10, so that's 11, over 1 minus 1/2. And so technically I could be done here and say that this is my answer. Now this one in particular you can simplify quite a bit. So if you distribute this exponent, you have 1 minus 1 over 2 to the 11. Because if you raise a fraction to a power, then the power gets placed on the top and the bottom. But 1 to any power is 1. And then 1 minus 1/2, that's 1/2. So flipping this denominator, the 1/2 comes up and becomes a 2. 1 minus 1 over, ignore this part, 2 to the 11, which is 2048. And now it's just basically a fraction problem. So you have 2 times, I need a common denominator of 2048, so I have 1 equals 2048 over itself, minus 1 over 2048, and so that's 2 times, if I have 2048 minus 1 over 2048, that's 2047 over 2048. And then finally I can cancel the 2 with that 2048. So that's 2047 over half of 2048, which is 1024. Okay, so that's a really simplified final answer. Although, personally, I would take this as an acceptable final answer. Okay, so let's try another example. So, for this one, I want to give you an example where you don't start at 0. If the series doesn't start at 0, it's not fitting into the standard form, and so our answer is going to be skewed just a little bit. So let's say our question is, find the value of this series, the sum where you start now at 2 instead of at 0, and we'll go to 10, and we have 1/2 to the I. So very similar to the first one, but we start at 2 instead of 10. And so we notice that it's not a very good sigma. If we start at 2, this series is basically the same as the last one where we started at 0, but it's missing the first two terms, the I equals 0 and the I equals 1 term. So what this series will equal is what we had That's what we had if we started at 0, but now since we're missing the 0 term and the 1 term, I have to account on this side for that, so that's 1/2 to the 0 plus 1/2 to the 1. And I have to subtract both of those off. So of course you can simplify this and get a different answer, but let's keep our answer like this. You just do a bunch of fraction stuff. And we'll look at a final example that looks a lot like the first one. And instead of writing out the problem, I'll just say, what if we start at 0 and now we let this top bound be a variable again, and let's say it's 5 to the I. If we want to find the value of this, the fact that this is a letter shouldn't confuse you. Just treat it like a letter, just like in the formula. So we have 1 minus 5 to the next highest power, which is n plus 1, over 1 minus 5. And that's our answer. So again, in this video we're applying the geometric series formula. We haven't yet seen where the formula comes from, but that's another topic. And that's it.